Alright, good day students. As you can see, what we have today is circle geometry. The area of the quarter circle is 16 pi cm squared. It is given. Find the area of the inscribed sector C, B, Q, H. Leave your answer in terms of pi. So how do we solve this type of problem? Let's begin by making some few construction. From H, we can construct perpendicular line here. Let's construct perpendicular line. You see it here. Let me call it here to be A. This is a perpendicular line. Mind you, there is a curve here and then perpendicular line. So let's call here Z. So that this height up to this extent, I call here T, is what they reduce. So we are given that the area of the quarter circle, that is, this quarter circle is Z, T, A, H, C. The quarter circle Z, T, A, H, C. Area A is equals to 16 pi r squared, 16 pi cm squared. So we also know that the area of a quarter circle is given by pi over 4 r what squared. We know it. So from here we can find the value of r. Pi can cancel out. You see, no, so we have r squared. Cross multiply. If you cross multiply, alright, let me make it very easy. 16 cm squared is equals to r squared divided by 4. So that when you cross multiply, you have r squared to be equals to 4 times 16 cm squared. So r squared is equals to 4 times 16 cm squared. That gives us r squared to be equals to 64 cm squared. So find the square root of both sides. You have r to be equals to the square root of 64 cm squared. And that gives us r to be equals to 8 cm. Now that we have gotten the value of r, that is, here is r, 8 cm squared. So let's return to the question. Sorry, so we can clean here to have space. The next thing we have to consider is we have to join TH as a straight line. Sorry, join TH as a straight line. It passes here. At this point, it's a straight line. So from here, we now have from triangle THA. THA, you have to use Pythagoras theorem to solve it. We call here HO to be r, small r, and we can join this line. You know, this center we call here r, so that we have B H to be equals to 2r, and then we have AH to be equals to r, and then we have TH to be equals to r. So once we have gotten these values, we can now apply Pythagorean theorem to find the value of small r. This r, we know that this big R is equals to 8 cm. So let's use Pythagorean to solve for small r. This gives us that th squared is equals to ta squared plus ha squared. So we can now substitute the values to solve for r. So th is equals to 8 squared equals to ta, or rather wait, so mind you, this is, if there is a point here, this point here, I can call it z. So that z, sorry, tz is equals to 8. ta not tz, ta is equals to 2r. Mind, this is a curve. Tz up to this point is equals to 8 cm. ta is equals to bh. This is a rectangle. This is a rectangle, not the curve, not at the extreme here. I don't know if you understand it. No, let me show you how it looks. This is the same as this is how it looks. It's supposed to be like this. Here is B, here is H, here is A, and here is Z, here is T. You see it? So in this case, TZ is equals to 8 cm, which is the radius of the quarter circle. TA is equals to what? Is equals to BH, which is equals to 2r. So here is equals to 2r. So TA is equals to 2r squared plus HA. Look at it. If you draw this line from here down here, notice that this is also equals to the radius. Here is radius. Is it not so? OQ is equals to BT, which is equals to R. Is also equal to HA. If we draw a line here from the center O, this is R. Here is also R. So that HA is equals to R squared. I hope you are following. So from here we have 4r squared plus r squared is equals to 5r squared. So you can simplify it. 8 squared is equals to 64. That gives us 5r squared. So that we can divide by 5. And once we divide by 5, we have r squared to be equals to 64 divided by 5. R squared is equals to 64 divided by 5. Now that we have gotten the value of r, we can now solve the required equation. Come up, we have gotten the value of the square of r. We got that r squared is equals to 64 divided by 5. So we can clean the board, we can clean here. We are required to leave our answer in terms of pi. Now that we have arrived at this point, you are asked to find the area of the inscribed sector. B, C, this is the sector, inscribed sector. You know what is a sector? Some part that is in the circle. A sector of a circle. If this is the center, this is a sector. No, this is an arc. This, if here is the center. This is a sector. This area is a sector. If you draw another line here, this is another sector. So find the area of the inscribed sector. You look at it, this it's not complete. So from here to this point is a sector. You need to find this angle here, and this here is 90 degrees. The total angle at a point is equals to 360. So 360 degree minus 90 degree will give us what? 270 degree. So this angle here is equals to 270 degree. The angle that make up this sector is 270 degree. So from that we can now use the area of a sector. Area of a given sector, if we call it A, is equals to theta over 360 times pi r what squared. I use r1 to differentiate from this. So to find this area of this sector, therefore area of the sector, in this case CB QH, I can call it A2, will be equals to what? Using the formula, substitute what you got. Theta here is 270 divided by 360 multiplying pi times r squared, in this case is 64 over 5. So simplify it, simplify the numerical expression. Here 90 divided this will give us 3. If you divide by 90 divided this will give us 4. 4 divided itself is 1. 64 divided by 4 will give us, I think, 16, because 6 divided by 4 is 1 carry 2. Put it in front of 4 to give us 24. 24 divided by 4 will give us 6. So you have now 3 times 16 will give us 48. Remember, pi over 5 cm squared, and that is the required area. So that is the required area of the sector CB QH is equals to 48 pi cm squared divided by 5. I hope you enjoyed this lesson. Please, before you go, do me a favor, subscribe to my channel to encourage me to bring more videos for your view. Like and share, others will be aware of these free videos I'm giving to you. Click the notification button whenever there is new update. You'll be the first person to receive it. I hope you enjoyed this lesson. See you in the next lesson. Bye for now.